With the convergence of top-tier operation models and data architecture, it could be argued that the real competitive advantage now lies in the proprietary context and reliability of a data platform. If you can manage the risks like hallucination and technical debt, perhaps agentic workflows are the way to deal with these issues. That's what we're exploring in this week's deep dive based on the Data Pro newsletter from April 22, 2026. If this version's a little bit TLDR for what you're doing right now, you can head over to our YouTube page and check out a summary version of this video from the Data Pro newsletter that we mentioned. It's all there on the front page, it's easy enough to find, and while you're there, why not hit that subscribe button so you can get these updates sent to you directly.
Picture this scenario. It's 3:00 a.m. Your pager duty goes off.
Oh, the classic data engineer nightmare.
Right. You log in, eyes half open, expecting to see a standard pipeline failure, maybe an API endpoint timed out, or a cluster ran out of memory.
Or a scheduled DBT job hit a null constraint somewhere. You know the drill.
Exactly. You look at the stack trace, you find the exact node that failed, patch it, and go back to sleep. But that's not what you see this time.
No, this time it's much worse.
The dashboard is completely green. Uptime is 99.9%. Latency is perfectly normal. CPU utilization is well within bounds. Every traditional metric tells you the system is flawlessly healthy.
Which is as scary as a thing you can see at 3 a.m.
It really is. Yet the customer support queue is just overflowing. And why? Because the automated financial advisor agent running on your platform has spent the last 4 hours reallocating client portfolios.
And is doing it based on a subtly corrupted interpretation of yesterday's bond yields.
Yes. The silent failure.
Right. The architecture didn't break, the logic didn't throw an exception, but the reality the system constructed was, fundamentally flawed.
And if you're listening to this right now, if you are a data engineer, a platform architect, or you're managing production AI pipelines, that scenario is probably your absolute biggest nightmare.
Oh, without a doubt.
Because we've spent decades, literally decades, building diagnostic tools that assume systems are deterministic. It's either broken or not broken.
True.
But now we're orchestrating agents that interpret, reason, and act autonomously. You aren't debugging code anymore. You're essentially debugging digital psychology over a long time horizon.
Which, requires an entirely different engineering paradigm.
Yeah.
The transition we're in right now is just staggering.
It really is.
Think about where we started. Prompting was just the warm-up. We threw a few strings at an API and marveled at the autocomplete.
Like a really advanced parlor trick?
Exactly. Then we moved to ARGI, retrieval augmented generation. We realized the model needed our proprietary context to be useful, so we just bolted vector databases onto our applications. That was our first real production pattern.
And from there, the entire discipline of context engineering just exploded. But right now, today, we are hitting a massive inflection point. The ground is shifting completely beneath us.
It is. We are moving from single-turn, stateless interactions to continuous, stateful, autonomous workflows.
And the downstream impact on the data platform is devastating if you aren't prepared for it.
That's the core thesis we need to dissect today. Model evolution is no longer primarily about the end-user chat experience. That's old news.
Right.
The real evolution is happening in the shape of the systems we build to feed and contain these models.
Okay, let's unpack this, because it is incredibly easy to get distracted by the noise,
Oh, absolutely. The flashy vendor demos.
The benchmark leaderboards, the arguments over parameter accounts on social media. We are going to ignore the paint job today. We are looking at the pipes and the plumbing.
The stuff that actually matters.
Exactly. We have a phenomenal piece of source material for this deep dive. It's a datapro.news article titled AI Model Evolution Hits an Inflection Point by Samuel Williams. It was published April 22, 2026.
It's a fantastic read.
Our mission today is to synthesize the 5 major trends Williams outlines, but strictly through the lens of data engineering and pipeline architecture.
The architectural framing is essential here. Williams' piece is basically a wake-up call for the infrastructure layer.
Yeah.
If you treat these upcoming frontier models the same way you treated a generic LM API a year ago, your pipelines will buckle. They will break.
Because they're doing so much more now.
Right. They're becoming more tool-native, multimodal by default, and they're expecting to operate as coordinated systems rather than just, isolated text generators.
So to really grasp the pipeline implications, we have to look at the catalyst. We need to look at the specific frontier model preview that is forcing the industry's hand right now.
We're talking about Anthropic.
I am talking about Anthropic's Claude Mythos preview.
Right. Project Glasswing.
Exactly. But I want to be incredibly precise here because The developer forums are currently drowning in speculation about Mythos.
It's out of control.
It is. We've got people claiming they know the exact mixture of experts' routing algorithm, the uncompressed parameter counts, the supposed AGI benchmark scores.
Which is all just rumors at this point.
Let's strip all of that away. Based strictly on Anthropic's official system card and the DataPro article, what do we actually know about Mythos?
Well, the verified facts are narrow, but they are deeply revealing. First, it is a highly restricted research preview.
Okay.
The prioritized focus, and this is the critical signal for engineers, is defensive cybersecurity. Anthropic is building and tuning this model specifically to navigate complex network topologies, monitor real-time threat streams, and execute defensive orchestration.
I want to push on that for a second. Why is the defensive cybersecurity label such a massive signal for a data engineer who, let's say, doesn't even work in security?
It's a great question.
Like, if I'm building an AI pipeline for retail logistics, why do I care what Anthropic's security model does?
You care because of what a defensive cybersecurity use case demands computationally.
Okay, what do you mean?
It is not a single-turn question-and-answer bot. To do defensive cyber, an agent must monitor systems continuously. It has to subscribe to event streams, ingest massive volumes of raw logs, maintain state over days or even weeks.
Wow, weeks?
Yeah. And it has to form hypotheses about anomalies, coordinate with other specialized agents to gather more context, and then execute actions across a distributed system.
It is the ultimate long-running job.
Precisely. And that fundamentally shifts the baseline capability we have to design for. We can safely assume the model's reasoning is going to be exceptionally strong.
That's a given now.
Right. The actual battleground, the place where this technology either succeeds or implodes in the enterprise, is system reliability. Mythos is promising extended autonomy.
It's like we've been obsessing over the raw horsepower of a massive new car engine. We've spent 2 years staring at the engine block, talking about the cylinders.
The benchmark scores.
Exactly. But now we are dropping that engine into a standard sedan, and we're realizing the torque is so violent, it's going to instantly snap the transmission the second we accelerate.
That's a perfect analogy.
The transmission is our data pipeline. If we don't build a drivetrain that can handle long-running, high-torque autonomous operations, the engine is useless.
I'd take that analogy even further, actually. It's not just that the torque will break the transmission. It's that the engine now has a mind of its own and will continuously keep driving, even after the transmission snaps.
Oh, man, grinding the gears into dust.
Grinding them into dust without even realizing it. For a data platform, a long-running job requires a hardened control plane.
Right.
If an agent is running autonomously for 48 hours, looking at your Kafka streams, querying your data warehouse, and invoking APIs, what happens when it encounters a silent data quality failure?
Let's walk through the mechanics of that. In a legacy pipeline, if a daily ETL job fails or produces slightly stale data, a human analyst spots it.
Usually.
They look at a Tableau dashboard, realize the revenue numbers look flat, submit a Jira ticket, and we backfill the data. The human is the circuit breaker.
The human provides the common sense check.
Exactly.
But when you remove the human and attach an autonomous agent directly to the pipeline, the blast radius becomes completely unconstrained.
Unconstrained. Because the agent doesn't know any better.
Right. The agent queries a materialized view. The view is 12 hours out of date because a DBT run failed silently.
Which happens all the time.
Constantly. But the agent doesn't possess intuitive doubt. It takes the stale data as ground truth.
Okay, so it sees the bad data.
It uses that data to decide that a specific network node is compromised. It triggers a quarantine protocol via an API, shuts down a critical service, and then writes a beautifully formatted report justifying the action based on the false reality you fed it.
And it does all that in, what, 400 milliseconds?
Exactly, faster than you could even blink. The entire risk profile of the data platform changes from provide data for analysis to provide an irrefutable reality layer for automated execution.
Which perfectly sets up the first major architectural shift Williams details in the DataPro piece, because if frontier models like Mythos are establishing this baseline of intense reasoning and autonomy...
And eventually every major vendor releases a comparable model.
Right. How does a company actually differentiate its AI products?
Well, according to the article, they won't differentiate on the model. The top tier of reasoning engines is compressing into a very narrow performance band for mainstream enterprise tasks.
So the easy gains are behind us.
Completely.
Yeah.
The days of plugging in the newest model and suddenly having a vastly superior product are ending.
See, I have to stop you there because the behavior of engineering teams right now completely contradicts that.
What do you mean?
I still see platform teams spending 3 weeks running massive bake-offs, meticulously comparing Claude 3.5, GPT-4o, and Gemini 1.5.
Oh yeah, the endless evaluations.
They're trying to declare a definitive winner to hardcode into their backend. If the capability is converging, why are we still so obsessed with benchmark micro-optimizations?
What's fascinating here is that it's an artifact of legacy procurement thinking. We are treating foundation models like database vendors.
Like saying, we're an Oracle shop.
Exactly. You should declare, we're an Oracle shop, and your entire architecture bent to accommodate Oracle. Teams are doing the exact same thing with LLMs today, baking proprietary vendor quirks directly into their prompts and orchestration logic.
But the Data Pro article highlights that the differentiation, the actual competitive advantage, is moving downstream.
Into the context.
Yes, into the context, the semantic tooling, and the reliability infrastructure.
You can swap models and see maybe a 2% variance in reasoning capability.
Right.
But if you fix your semantic layer and stop feeding these agents ambiguous definitions, you see a 5% increase in operational reliability.
Let's dive deep into the semantic layer, because I feel like semantic layer has become a buzzword that gets thrown around in marketing copy without much technical weight.
It definitely has.
When we talk about feeding an agent contradictory definitions, what is actually happening at the data layer?
Okay, let's build a scenario. Imagine a standard enterprise data warehouse. Your marketing team's DBT models define an active user as any account that opened an email in the last 30 days.
Makes sense for marketing.
Right. But the product team's tables define an active user as an account that logged in and executed a core transaction in the last 7 days.
Very different metric.
And the finance team defines it as an account with an active billing subscription, regardless of login activity.
So you have 3 totally valid yet completely contradictory realities living in the exact same Snowflake instance.
Exactly. Now, when humans navigate that, they have institutional knowledge. A human analyst knows to pull from the finance schema when calculating revenue.
They know who to ask if they're confused.
But an autonomous agent doesn't have that tribal knowledge. When tasked with a workflow, it queries the enterprise vector index or executes a broad SQL search, and it retrieves all 3 definitions simultaneously.
Oh man, and what does the agent do when its context window is loaded with 3 conflicting truths?
Well, it attempts to be helpful. It either silently averages the definitions together, creating a hallucinated 4th definition that is literally useless to everyone.
Which is terrifying.
Or it confidently anchors onto whichever definition happened to be retrieved first or had the highest vector similarity score, completely regardless of the business context of the task.
So the data platform's mandate changes entirely. The mandate is no longer just make data available. It is provide absolute context-aware truth.
Right.
Williams states the new engineering imperative is to make model swap cheap. We need an abstraction layer.
Yes. Because if your pipeline code treats a specific model as a permanent dependency, you are already accumulating severe technical debt. If you are writing prompt templates optimized for one model's specific attention heads, or relying entirely on a vendor's proprietary JSON mode schema, you are trapped.
Because the moment a new open-weight model drops that handles your exact workload with 60% lower latency and half the inference cost, you can't migrate.
Exactly. You are stuck refactoring your entire ingestion and orchestration layer just to change the model.
That's a nightmare.
It is. The product that the data engineering team builds is no longer a static dashboard. The article puts this beautifully. You have to treat context as a runtime product.
A runtime product. I like that phrasing.
The semantic definitions, the data freshness indicators, the trust metadata, these can no longer be static PDFs sitting on a Confluence page.
Because the agent can't read Confluence.
Well, it can, but it doesn't know how to interpret a stale PDF versus live table definitions. They have to be live, queryable APIs that the agent interacts with before it even attempts to formulate an answer or take an action.
Which introduces a whole new layer of complexity when you consider what these agents are actually doing. We are moving away from single-turn generation. We are no longer just sending a chunk of text and asking for a summary.
Right. The deployment unit has fundamentally shifted. We are deploying agentic workflows.
These are complex, multi-step operations, and because the workflows run longer and involve multiple API calls, database reads, and conditional logic branches, the nature of pipeline risk changes entirely.
Error propagation is the new ultimate threat.
Let's talk about that. Think about the mechanics of error propagation in a DAG, a directed acyclic graph.
Yeah, that's the best way to visualize it.
I want to break down exactly how an LLM workflow functions as a DAG, because we usually think of DAGs in the context of orchestrators like Airflow, where task B waits for task A's SQL query to finish.
Yeah.
How do we map that onto generative workflows?
Okay, so in an agentic workflow, each node in the DAG is an LLM call or deterministic tool execution. Node 1 might be retrieve user history. The agent queries a database and synthesizes a summary. Node 2 is identify refund eligibility. It takes the output of Node 1 and checks it against policy documents.
Got it.
Node 3 is draft communication. Node 4 is execute sand.
The blast radius problem again?
Exactly. Imagine Node 1 retrieves the history correctly, but hallucinates a single transaction ID during the synthesis step. It swaps a 5 for a 6.
A tiny, seemingly innocuous error a human might not even notice.
But because it's a DAG, Node 2 accepts that hallucinated transaction ID as absolute ground truth. It queries the refund database for the wrong ID, gets an error, or worse, gets the refund data for a completely different customer.
Oh, wow.
By the time the workflow reaches Node 4, the agent is sending highly sensitive, incorrect financial data to the wrong person. A hallucination early in the graph poisons the entire downstream execution.
This completely destroys the old narrative around hallucinations.
Yeah.
I remember a year ago, the dominant thought leadership was, just wait for GPT-5. The models will get so big they will simply stop hallucinating.
Yeah, that naive hope is dead.
Thank goodness.
Williams makes it clear that the industry has reframed hallucinations. It is no longer an AI research problem, it is a data infrastructure problem.
If we can't trust the model to never lie, how do we build infrastructure that survives the lies?
You implement DAG-based verification loops. You do not allow a generative node to pass its output directly to an action node.
So what do you put in the middle?
You insert deterministic or highly constrained verification nodes in between.
But practically speaking, how does a data engineer build that? I can't just add a system prompt that says, please review your work carefully and ensure you aren't hallucinating. We all know that doesn't work.
Right, the model will just confidently tell you, I have reviewed my work and it is flawless, while outputting absolute garbage.
Exactly.
You're touching on the fundamental flaw of asking a model to self-correct using the same context. It doesn't work because of something the DataPro article identifies as parametric knowledge bias.
Parametric knowledge bias. That concept absolutely blew my mind when I read it. Let's spend some time here. What is mechanically happening inside the neural network when this occurs?
Okay, we need to look at how these models weigh information. A foundation model is trained on a massive corpus of internet data.
Billions of tokens.
Right. The statistical relationships between those billions of tokens are baked into the model's weights, its parameters. That's its parametric knowledge.
Okay, I follow.
Now, in a production RAG pipeline, you inject a piece of your proprietary enterprise data into the prompt and essentially instruct the model, ignore everything you learned on the open internet and answer this query using strictly the context I am providing right now.
We're asking it to temporarily override its entire worldview based on a few paragraphs of text we retrieved from a vector database.
Exactly. But parametric knowledge bias occurs when the model's deeply ingrained internal weights strongly contradict the retrieved context.
Like a stubborn employee who thinks they know better.
That's a great way to put it. The model knows a fact so thoroughly from its pre-training that its attention mechanisms actively suppress or ignore the proprietary context you just handed it.
So the data engineering pipeline did its job perfectly. The embedding model worked, the vector search was flawless, we retrieved the exact right document from the corporate wiki, we placed it perfectly into the prompt.
And the model just looked at it, decided, nah, that doesn't look right, and hallucinated an answer based on its pre-trained weights anyway.
Unbelievable. The model overrules the pipeline.
This is why standard RAG is failing in complex enterprise environments. And it forces a total paradigm shift for platform teams.
It's not just about search anymore.
No, it is no longer sufficient to just retrieve relevant context. Your retrieval and orchestration layer must be engineered so strictly that the model is forced to obey it.
Okay, but how on earth do you force a multi-billion parameter neural network to obey?
By implementing strict cite or silent policies at the infrastructure level.
Let's get into the weeds on this. What does a cite or silent architecture actually look like in the code?
It means you require the model to explicitly construct a valid citation graph for every declarative statement it generates.
Okay.
You segment your retrieved context into heavily indexed chunks, passing exact chunk IDs or line numbers to the model. You prompt the model to append the relevant ID to every sentence it writes.
But wait, the model can hallucinate the citation ID too. I've seen models make up completely fake line numbers to justify a hallucinated fact.
Well, they do it all the time, which is why the verification loop happens outside the LLM.
Ah.
You parse the LLM's output programmatically. You extract the generated claims and the generated citation IDs. You then run a deterministic check. Does the claim actually exist within the exact string of text associated with that chunk ID?
How do you check that? Another LLM.
You can use a smaller, highly constrained, specialized model, like an NLI or natural language inference model, whose sole job is to evaluate if premise A supports hypothesis B.
Ah, so you have a massive reasoning engine doing the generation and a tiny, cheap, fast validator model doing the fact-checking.
Yes, and if the validator model cannot confirm that the source text explicitly supports the generated claim, the entire node fails.
You just fail.
It returns a programmatic null. The workflow halts. It goes silent.
I can hear product managers screaming right now. You want to halt the workflow and return nothing? The user experience will be terrible. The latency will be horrific if we have to run a secondary NLI check on every single sentence.
I've had those exact arguments with product managers.
I bet. How does a business operate when the data platform is constantly rejecting the agent's outputs?
You have to look at the alternative. The alternative is allowing the agent to silently corrupt your downstream systems.
Which goes back to the 3 a.m. pager duty nightmare.
Exactly. You have to choose your failure mode. Do you want a system that occasionally says, I cannot proceed with sufficient confidence? Or do you want a system that confidently rewrites customer contracts with hallucinated clauses?
I'll take the silence, thanks.
Right. The infrastructure mandate is to upgrade the substrate.
The substrate being the foundational data layer.
Freshness beats cleverness. Semantic correctness beats massive parameter counts. And an airtight, verifiable retrieval architecture beats a slightly better reasoning score. The platform team must establish query time authority.
Let's define query time authority. What does that mean for a team?
It means instrumenting grounding confidence as a core metric. You need telemetry that tracks exactly how often your system is refusing to answer.
Okay.
You need to set threshold SLOs, service level objectives.
Huh?
Just like you measure API uptime, you must measure hallucination risk. If you don't know your refusal rate, you have absolutely no idea how much operational risk your agents are taking.
We have to treat the propensity to hallucinate not as a quirk, but as a quantifiable system metric that triggers alerts when it spikes.
Absolutely. It has to be on a dashboard.
All right, so we've established that we need these rigid DG-based verification loops. We need secondary validator models checking citations. We need meticulous chunking and indexing to maintain this illusion of control.
Right.
But here is the massive curveball Williams throws in the article. Just as platform teams are finalizing these incredibly complex RAG architectures to feed models carefully measured, 512 token bite-sized chunks.
The ground shifts again.
The underlying model architecture is fundamentally changing. The physics of the pipeline are about to break again.
The million token wrecking ball.
We are entering the era of post-transformer architectures. We are talking about state space models, Mamba architectures, hybrid stacks.
Right.
And the defining characteristic of these new models is their ability to handle massive context windows, million token scale, with linear time compute characteristics.
And we really need to explain why that linear time aspect is so revolutionary, and also why it's a trap.
Let's start with the revolutionary part. In a standard transformer architecture, the attention mechanism scales quadratically.
Which means?
If you double the amount of text you put in the prompt, the computational costs and the latency don't just double, they quadruple. It gets exponentially more expensive.
Right.
Which is exactly why data engineers spent the last 2 years building complex vector databases to ensure we only send the most relevant tiny slice of data to the model.
But state-space models process sequences differently. They scale linearly.
So doubling the context only doubles the compute.
Exactly. The latency penalty drops massively.
So as a data engineer, my immediate instinct is, Thank God I can finally rip out all this complex vector search infrastructure. I don't need to tune chunk sizes anymore.
Just feed it everything.
If the model can ingest 1 million tokens cheaply and quickly, I'm just going to dump the entire user history, the whole corporate wiki, all the Slack logs, and the last 10 years of Jira tickets directly into the prompt. I'll let the AI sort it out.
It sounds so appealing.
It does. So what is the fundamental flaw in that logic?
If we connect this to the bigger picture, the flaw is confusing data volume with data quality. A massive context window does not fix bad semantics. It exponentially amplifies the blast radius of bad context.
Walk me through the mechanics of that failure. If the model can see everything, why can't it find the right answer?
Let's go back to our active user example, where marketing, product, and finance all have different definitions.
Okay, the 3 realities.
If you dump 1 million tokens of raw, unfiltered enterprise data into the prompt, you are guaranteeing that the model will ingest all 3 contradictory definitions.
Because you didn't filter anything out.
Right. You are guaranteeing it will ingest the obsolete Q3 financial forecast from 2022 alongside the current Q3 forecast for 2026.
You are burying the truth in a mountain of noise.
You are demanding that the AI model perform complex data deduplication, temporal reconciliation, and semantic alignment on the fly, entirely within its own weights across a massive sequence of text.
That's a lot to ask.
It's too much to ask. The model has to figure out which timestamp is valid, which department's definition has authority, and which document supersedes the other.
And it will fail.
It will fail catastrophically. The hallucination rate will skyrocket, not because the model is dumb, but because you fed it a schizophrenic reality.
It's just trying to make sense of the chaos.
Exactly. The model doesn't know that the marketing PDF from 3 years ago is deprecated unless you tell it.
So giving the model more context actually degrades its reasoning if the context hasn't been rigorously curated.
This is why hard-coding chunk logic into your pipeline today is severe technical debt.
Let's unpack chunk logic. If a team is running a production pipeline right now, they likely have a Python script somewhere that says, split these incoming PDFs into chunks of exactly 500 tokens with a 50 token overlap.
Yeah, that's standard practice.
And they have vector database settings tuned to return exactly the top 5 nearest neighbors.
All of those are hard-coded assumptions based on the context window constraints of whatever model they deployed 6 months ago.
And Williams argues that maintaining those constants is a liability. So how do we build for variability? What does a dynamically configurable context architecture actually look like?
It means you abstract the chunking logic away from the core ingestion pipeline.
Yeah.
You treat your vector index strategy as a configurable operational parameter.
How does that work at runtime?
If the orchestrator routes a query to an older quadratic transformer model, it dynamically applies the 500 token chunk profile.
Okay.
But if the system routes the task to a new linear state space model, it swaps to a document-level chunk profile, maybe passing 10,000 token chunks.
So you build an ingestion framework that can gracefully evolve toward fewer, larger chunks without requiring a ground-up rewrite of your entire indexing pipeline.
Crucially, you must start establishing telemetry baselines right now. You need monitoring that tracks the inference cost per token, the retrieval latency, and the end-to-end time to first byte.
Because if you aren't measuring it today, when the platform team comes to you in 6 months and says, let's swap to this new 1 million token state space model,
you won't actually know if it's saving you money or quietly destroying your cloud budget.
You are flying completely blind.
Exactly.
This brings us to the ultimate friction point. We have these massive context windows. We are designing abstraction layers to swap models seamlessly. We have autonomous agents executing multi-step DEG workflows.
And we are giving these agents access to enterprise databases and APIs.
We are handing them the keys to the kingdom.
Which is terrifying.
It really is.
Yeah.
How does a data platform team prevent total systemic chaos? How do you secure an architecture where the primary actors are non-human entities with massive execution speed and no inherent sense of operational boundaries?
This brings us to the final trend. Governance is hardening. It is transitioning from a policy document to a strict protocol and permissions layer.
I found this section of the Data Pro piece incredibly vindicating.
Oh, me too.
Because for the last 2 years, AI governance usually meant a committee of executives wrote a 40-page PDF about ethical AI use and put it on a shared intranet drive.
A PDF policy document cannot intercept a REST API call.
No, it cannot.
It cannot stop an autonomous agent from executing a drop cable command in your production database.
Precisely. Governance has to become a programmatic interface. Williams explicitly mentions MCP, the Model Context Protocol, as an emerging standard for tool discovery and permissions.
We need to look at the disease MCP is trying to cure, which is agent sprawl.
Let's define agent sprawl, because right now, the way teams are giving agents tools is completely chaotic.
It is the Wild West out there.
Yeah.
The marketing engineering team builds an agent to analyze campaign performance, and they write a bespoke Python script that lets the agent ping the Salesforce API.
Okay.
The DevOps team builds an agent to analyze logs, and they hard code some AWS credentials into the prompt wrapper so it can restart a server.
Every team is bolting tools onto their models using bespoke, undocumented, unmonitored code.
And the result is a catastrophic security posture. You end up with invisible data exfiltration paths.
What's an example of that?
You can have a customer service agent that can theoretically read sensitive HR data simply because someone gave it broad API access to be helpful.
Oh, wow.
And when you inevitably need to rotate a credential or revoke a permission, there is no central control plane. You are hunting down custom Python scripts across 20 different repositories.
We're recreating the exact same spaghetti code integration nightmare that we spent the entire last decade cleaning up in the microservices era.
Exactly. We learn nothing. So what is the solution? Think of it like physical security. The bespoke method is like hiring a new intern and handing them a master physical key that opens every door in the corporate headquarters.
And just hoping they only go to the cafeteria.
Right. The protocol method, the MCP approach, is giving the intern an RFID badge.
Oh, okay.
That badge is managed by a central security system. It only opens specific doors, only during designated business hours, and every time the badge interfaces with a lock, the system logs the exact timestamp and identity.
The data platform must become the RFID system for AI agents.
Tool access must be treated as a native component of the data platform. You don't let agents reach out to APIs randomly.
You force them through a gateway.
You force them to go through a standardized gateway where they dynamically discover what tools they're authorized to use, and every single execution is intercepted, validated against an RBAC, a role-based access control policy, and logged.
Okay, this is an immense amount of architectural complexity.
That's a lot to take in.
We've navigated the shift from prompting to long-running defensive cyber agents. We've talked about the convergence of frontier models requiring us to treat context as our main product.
We've broken down DIG-based verification loops to fight parametric knowledge bias.
We've explored why massive context windows are a trap without dynamic chunking. And we've just covered standardizing tool permissions via protocols like MCP.
It is a complete re-architecture of the enterprise data stack.
And thankfully, Samuel Williams doesn't just leave us with theory. The article synthesizes all of this into a practical build plan for the next quarter.
Yes, the tactical stuff.
It outlines 5 highly specific, concrete steps that data engineering teams need to execute. Let's really dissect these, because this is the operational roadmap for anyone listening.
Let's start with step 1. Build contextual layers as runtime primitives. The article defines 5 specific layers you must engineer: semantic context, temporal context, relational context, quality context, and governance context.
Let's break those down. What does building a semantic context layer actually mean in the code base?
It means making your business logic machine readable. It means instead of relying on human analysts to know what active user means, you deploy a metadata API.
So the agent can query it directly?
Yes. When an agent receives a query about user growth, its first step is querying the semantic API to retrieve the exact approved SQL logic for active user.
Okay, what about temporal context?
Freshness. The agent must be able to algorithmically determine how old the data state is.
And relational context?
Relational context means exposing your entity relationship diagrams or knowledge graphs to the agent so it understands how the billing tables map to the product telemetry tables.
Quality context is trust signals, which we will get into in a second. And governance context is the tool discovery protocol we just discussed.
Right. If you do not construct these layers, the immense reasoning capability of a model like Mythos doesn't translate into business value. It translates directly into uncontrolled operational risk.
Which leads perfectly into step 2. Ship queryable trust metadata.
This one is huge.
The directive here is to inject metrics like data quality score and last validated at directly into the datasets. I want to emphasize how much of a mindset shift this is.
It changes everything.
Traditionally, data quality metrics live in a separate observability tool. A data engineer looks at a Monte Carlo or Datafold dashboard to see if a table is healthy.
But the agent cannot look at a human dashboard. You cannot trap trust signals in a separate pane of glass.
So how do we inject this?
You embed the metadata directly into the vector payload or the database schema,
Like literally in the JSON.
literally in the JSON. If your ingestion pipeline calculates that a specific document hasn't been updated in 18 months, you attach a JSON metadata tag, last validated at 2024-11-01.
Okay.
You create a calculated data quality score based on pipeline run successes and attach it to the row.
So when the agent retrieves the data, it isn't just reading the text, it's reading the metadata, and its system prompt dictates. If the data quality score is below 0.8 or the last validated timestamp is older than 30 days, do not use this context. Trigger a fallback protocol.
You are giving the agent the algorithmic capacity for doubt.
Step 3. Make chunking configurable. We hit this hard earlier. Evolve your vector index strategy away from hard-coded token limits.
Build a pipeline that can dynamically scale chunk sizes based on the model's architecture, whether it's a legacy quadratic transformer or a linear state space model.
Step 4 is perhaps the most critical for reliability. Measure grounding and refusals. Hallucination risk must become a production SLO.
Yes.
How do you practically measure grounding across 10,000 automated workflow executions a day?
You log the output of the secondary verification nodes we discussed earlier.
The NLI models.
Right. Every time the NLI validator model rejects a claim, you increment a counter. You track citation coverage, what percentage of generated sentences successfully linked back to a verified chunk ID.
And you put that on a dashboard.
You put those metrics on the exact same Grafana dashboard as your compute costs and your API latency.
So if your refusal rate suddenly spikes from 2% to 15%, you don't blame the AI model.
No, you investigate your ingestion pipeline because your semantic context is likely corrupted.
And finally, step 5, standardize tool permissions early.
Adopt an auditable boundary.
Whether you choose the model context protocol or build an internal API gateway, mandate that all agentic tool use flows through a single, centrally authenticated, RBAC-enforced choke point managed by the data platform.
No bespoke Python scripts. No hard-coded credentials and prompts.
If you implement these 5 steps, you transition from running experimental chat apps to running a hardened, enterprise-grade execution engine.
It's a lot of work, but it's the only way forward.
So as we pull all of this together, the overarching mental model for 2026 is crystal clear. The era of obsessing over the AI model itself is ending. The model is merely the reasoning engine.
The model is the CPU. The data platform is the operating system. The data platform is the control plane.
And the teams that survive this inflection point are the ones who internalize that hierarchy. If you are listening to this, this is the reality of your job now.
It really is.
For decades, data engineering was fundamentally about serving human consumers. You built intricate pipelines, materialized views, and massive data warehouses so that human executives and human analysts could look at the data, apply their human common sense, and make decisions.
The ultimate consumer was forgiving. A human can spot a glaring anomaly and ignore it.
But today, the primary consumer of your infrastructure is non-human. These autonomous agents are incredibly fast, incredibly capable, and entirely unforgiving of ambiguity.
They possess zero common sense.
None. They only know the reality that your pipeline feeds them. If you feed them conflicting definitions, stale data, and unverified context, they will execute catastrophic workflows at light speed.
The data platform can no longer act as a passive supplier of tables. It has to elevate itself. It must become the absolute, irrefutable reality layer for these autonomous systems.
We started this deep dive talking about the nightmare scenario, waking up at 3:00 a.m. to debug a system that appears perfectly healthy on every traditional metric, but is behaving chaotically.
Because the reality layer was flawed.
Exactly. The old diagnostic tools are broken. The only way to navigate this murky landscape is to build infrastructure that enforces absolute semantic clarity at runtime.
You have to build the certainty into the substrate itself. You cannot rely on the model to figure it out.
So I want to leave you with a final thought to mull over. We are entering an era where agents will act as workers with long-running autonomy, executing multi-step workflows over days or months. Your data platform provides their entire perception of reality.
Their entire worldview.
If that is true, at what point does the role of the data engineer transition from simply managing data pipelines to essentially managing the digital psychology of a non-human workforce?
That is the defining question of the next decade of software architecture.
Think about the mechanics of that. How will you debug a catastrophic logic failure when the underlying data in the warehouse was perfectly accurate, the API endpoints were up, but the long-running context in the agent's memory was subtly, invisibly poisoned by a cascading semantic error over 48 hours of autonomous operation?
It's a whole new frontier.
What does the stack trace for a psychological breakdown look like? Keep questioning your infrastructure assumptions because the paradigm has already shifted beneath our feet. Thanks for joining us on this deep dive.
Thanks for checking this out today. Don't forget, you can connect with other data professionals worldwide on our growing school platform. It's all linked in the description, so pop along, come in, have a chat, and check out the exclusive resources there for data professionals like you. And if you haven't done so already, please feel free to like, share, or subscribe to the channel.